Thanks, Alex. Right, cool. So let's talk about PowerScale. So first of all, who am I? My name is Lee Jeffries. I'm a current CTP, independent consultant in the UK, working around Europe, and a father of three. I like to contribute to the community once in a while. I'm a general purpose geek, and I love running and water sports. So in a nutshell, pretty much up for anything as long as it includes some sort of alcohol and some sort of tech. So this sort of conference, pretty much perfect. All right, so it's quite a packed agenda actually for this one. So I want to talk about public cloud provisioning and how machines are built up, the sort of lead time you have for logins and things like that. How I think PowerScale fits into this, where PowerScale came from, how we install the solution or install the script and configure it to get it to run. And just to be clear, this is something that's going to help you manage workloads in public cloud using Citrix infrastructure in particular. And then we'll talk about the configuration and some of the options. So there's a fair amount of text here. I've got a bit of a video demo, a few pictures and things. So fingers crossed we'll keep you relatively entertained. And then lastly, we'll go through like a dashboard overview. So the script generates a dashboard to show you what it's been doing, and so you can sort of track back historically. So looking at public cloud in particular and thinking about how we've got shared sessions and virtual desktop environments. And this is sort of what I suppose, typical environment would look like during a week, right? We've got users that log in during the day, they log off during the evenings. So it's a typical example of a week in a remote desktop environment. Each day represents users logging into an environment and then logging out again. When we think about that graph, we look at something along these lines. So in a single day, we've got users up the left and we've got time down the bottom. So that's the sort of format I'm going to be referencing for these other graphs that I'm going to be looking at. So here we've got a 600 user environment where all users are logging in and working within a period of 60 minutes. Right, so you've got that sort of ramp up on the left, and it's quite sharp because we've got that amount of users. Okay, so you can see by the graph the log on rate is quite steep. Here we have 1100 users for one day. So you can see now that the ramp up is even steeper. All right, so all users are still required to be logged in within an allotted time frame of 60 minutes. How do we manage this? You know, there's a challenge with that. So we obviously need to provision these machines for these users. As we all know, we have a time frame for these machines to be ready, right, to actually provision and then to be ready for the users to log into. So if we're working in public cloud environments, we've got a challenge there, right? And we need to find a way of sort of addressing that challenge or planning for that challenge. So if we're not using reserved instances in a cloud environment, we need to think about having the machines ready and provisioned. We're not using reserved instances because obviously it's the cost to keep them running or the advanced cost when we could actually be scaling up and down. So we want to be as flexible and agile as possible. So another fact to consider, we can keep the persistent machines available and just power them on, or we can create on startup and destroy on shutdown. We save further money by creating on startup and destroying on shutdown, but there is of course more of a lag on the machines being available by creating them on startup. So for them to be ready for that, for the users, and including sort of your ramp up time in the morning, your log on rates. So we're back to the old balancing of user experience and cost, because obviously we could have users waiting to log in the morning. So if we look at some examples, right? So for 1,000 users to be able to log in the period of time required, we actually need to provision machines earlier than required. And then in order to cope with the login window, in this example, we actually need enough machines for 1,200 users in order to provide the availability for 1,000 users, right? If their login rate is, say, within a 30-minute time frame. So that's just the number of machines required, right? So it looks something like that. So we need a 20% buffer in order, with a deploy speed of 150 sessions a second. And these are rough numbers to illustrate this problem, right? But specifically, we've got to have that buffer to be able to cope for the log-on rate, and then in order to be able to cope with the deployment of machines and actually then be ready. So that actually looks like this. This means that 20% buffer effectively ends up with 35% of our servers being empty. So that's a fair amount of money being wasted, right? What happens if we change our login rate, how many sessions we actually need to be available, and we change our numbers? So faster login rates, we've got a deployment time to consider here as well. We need to start a certain number of machines before login starts to allow for the deployment lag and the login periods. So now we've got more machines we need as a buffer. So there's our login rate, and then we've got our buffer. So what does that look like? So now we're looking at 49% more money. And then if you really scale that up to a large enterprise environment, we're talking 10,000 users, what happens here? With the original 150 sessions a second, we now need a larger number of machines to cope with the deployment lag and login rate. Not so fantastic, right? And that actually equates to 57% empty. So there's always challenges when you're working in public clouds. So it's slightly different, right? Because we haven't paid for this tin. We're just using, we're paying per usage. So how did that stack up across a number of different organizations? So this is a survey from VDI Like a Pro, and it was asking, what's their concurrent user sessions for a server-based compute environment? And it looks something like this. So the higher numbers, we're talking 15% of all organizations are going to have a challenge similar to those slides, with the slightly smaller number being 24%. But the majority of those VDI environments are quite large. So we've got that. We've got spinning these machines up, the deployment lag. Then we've got something else to worry about. We've actually got cloud API limits. So don't forget cloud API limits or API limits in cloud environments. Every cloud provider has them. And if you are planning to spin up many machines all at once, you'll need to make sure you're able to respect these limits. There are ways to handle these limitations, such as requesting an increase or split your subscriptions out. But bear in mind that PowerScale, AutoScale, third-party providers, they all use API calls to be able to perform their function inside public cloud environments. So make sure this question is on your list for any suppliers that you're working with, and see how they recommend you manage it depending on what you're using. Specifically for Azure, you can run this command and it will give you the count of API requests you have remaining. Okay, so looking at our problem and then try and work out some of the answers, right? A big multi-session VM is the answer. Maybe. This depends on your business. Lots of smaller machines may not necessarily be efficient without a predictable user pattern. So larger machines can be more difficult to clear and shut down. So it's not necessarily the answer, although it may help you with your costs. So there's no direct answer to this, right? You've sort of got to work out what's better for your business model and what your user experience needs to look like. What about load balancing methods? Okay, so consider your load balancing methods as well. Citrix in particular introduced something called vertical load balancing. So horizontal load balancing will spread the users evenly across any VMs you've got available, whereas vertical load balancing will ensure that each machine is fully populated before starting another machine up. So balance this with your login rate and deployment time. and you know, it's something else to add into the mix. So let's look at what happens at the end of the day now. So we've talked about the start of the day and the machines needed to be available, but what actually happens at the end of the day when the users are going home? Because we've also got something to consider there, right? That's going to cost us some money too. So the red box is a server and the blue boxes are users. So blue boxes disappear and the users logging out. So on a nice day, everybody logs out sequentially, just like robots, and we're happy because we can shut our server down. However, in reality, it looks more like this. Everyone logs out randomly, and eventually we end up with the server empty and we can shut it down. But what happens if we do that across a larger scale? So we've got 512 users, right? Across a number of VMs. So they're all logging out, and we're just hoping that eventually we'll clear down a server. And I suppose the question really is, how many of these users have to log out before we can start shutting machines down? Yeah. So this is what it looks like with 25% of the users gone. We still haven't managed to shut a machine down. So we carry on. It's a good job it's not a manual process, because we'd be sitting there for a very long time. %, still not enough. Still haven't managed to shut down a single server. So now we're aiming for our 75% mark. Still nothing, right? 75% gone, still haven't managed to shut down a server. Okay, so 78% of my user estate has had to log out before I can shut a single server down. I keep going. So I'm aiming, I want to shut down 50% of my servers. It's getting there, right? Let me just jog it along. So shutting these down, it's taken me a while. Let's do it again, a bit quicker. And these simulations are completely random, right? All generated with PowerShell. Not courtesy of me, courtesy of Mr. Jim Moyle. He has lent me these slides to illustrate this. Okay, so 19 users left, or 4% of the population. So 96% of my users had to log out before I could shut down 50% of my servers. So that looks pretty dire, because actually we're always going to have, you might as well plan for always to have 50% of your servers running. So Bob there's very happy. He's managed to break the chain and escape. And we're happy as IT admins because we've managed to shut down a server. 96% of people have gone home and logged off. So who wants their users to work late? So a number of these simulations have been run using a script, selecting completely random numbers. And this is what it looks like if you've got 56 users per server. So it's got to be a beefy server, right? So we talked about big VMs. And I said we've got horizontal and vertical load balancing. So if I've got a big VM, I'm using vertical load balancing to pack it out. The first simulation yields these numbers. So I need to, for 256 users, I need to log out 100% of my users before I can shut down a server, basically, or 50% of my state. Then it's 99% for 128. And you can see a pattern occurring here. Essentially, we have to log out a lot of users before we're able to shut down 50% of those machines. There is a nice equation for this. And this equation looks like that. So probability a server is empty equals the probability of a single user being logged off to the power of the users per server. So it's pretty shocking, actually. But I don't think we always look at it like that as IT admins. We actually expect our users to log off, but evidently people work harder than we think they do. So so it's something to consider. And that brings me to PowerScale. All right, so PowerScale was something that I put together originally to help a single client, and essentially they were using Citrix SmartScale, and Citrix decided if you were not a Citrix Cloud customer, you wouldn't have a scaling option in the cloud anymore. So they deprecated SmartScale, and anyone using Citrix on-prem but with workloads in the cloud could not use that. So what happened was we needed a replacement. So I wrote one, and then I put that in the community and got some feedback, and it's sort of been evolving ever since. So I ended up with this this script that relies on Citrix broker infrastructure, so delivery controllers, and it talks to the delivery controllers to get the status of your machines, and it's able to power manage machines in any environment, on-prem or in the cloud, and shut them down and manage them for you. And it creates some nice dashboards and stuff. So what I'm going to run through now is what it does and how you configure it, how you set it up, and then once you've got it set up, what are the options. So what does PowerScale do? It lets you schedule machines, shut down, start up. So essentially that buffer that you've got in the morning, PowerScale can actually do that for you. It can spin up 20% of your machines in the morning, and then it can actively scale those for you if it wants to. It can scale machines based on CPU, memory, load index, or sessions. It can also generate dashboards, which will tell you what it's actually done. It generates a log. Those can be kept for historical reasons, and then it can also gracefully or forcefully log users off out of hours. It works between different business times. So you just have to say when you want to start and when you want to stop, and it will try and tailor the numbers of your session servers that you've got available to those parameters. So it's a very simple process to set this up. You download it, you configure it, and then you run it. Pretty simple. It runs with a scheduled task, preferably on a delivery controller, but it doesn't really have to be on a delivery controller. I don't always run it on a delivery controller. You can customize it to your business needs. You can put things in like the working days that you have, whether you're a standard business that works Monday to Friday, Monday to Saturday, whatever. And there's a wiki for it too. So on GitHub, the code's all publicly available. There's a World of EUC Slack channel for it where people write comments who are using it and ask for certain bits and pieces to be added. But I'm still working on it, still maintaining it, and it's still being used in organizations. So what am I using? I've got a relatively extensive lab, but just for the purposes of me developing it, this is what I have: a single domain controller, a single delivery controller, and then 6 MCS session servers. Obviously, a production environment's larger, but this allows me to tweak the settings and just test anything that needs testing, really. So to run PowerScale, you need the following prereqs. You need a Citrix environment, obviously. Now, with Citrix Studio, so just install Studio on the machine you want to run it on. That installs the PowerShell SDK. If you want to, you can install the SDK individually on its own. You need Windows Remote Management enabled. That's how it grabs some of the performance metrics for the machines. Obviously, it's checking the CPU load, memory load, and everything like that on the machines that it's servicing. And I'd recommend you having a service account that actually does that checking for you, so that you can lock that down and make sure that you're not having to run this with an admin account or something similar. But there's full instructions on the wiki, so go and have a look. So head over to GitHub, download the script, pop it in a folder. I say C PowerScale, and then extract the contents. And that's what you should see, right? You'll have a template folder, a couple of scripts. Very simple. There is a PowerShell script in there called create config. Open that up, pop in the details. There's comments on all of those on the right-hand side. So as you're running through this, it's going to be quite simple. and informative. So the settings that you need to configure, just as a bare bones, tell it what the name of your Citrix controller is that it needs to communicate with. Now, there's different ways of detecting which machines you want it to manage. You can do machine catalogs, delivery groups, tags in Studio, or you can use a machine prefix. And that's just literally a part of, or what the name starts with, and it'll find the machines for you. Put in your business start times, end times, how many out of hours machines you want, how many in hours machines you want, and then fill in the credentials for the service account if you're using one, right? If you're going to run it with an account that has admin rights to do all the stuff anyway, doesn't matter. The most important bit at the bottom of that config file is a variable called testing only. Mark that to true if you're going to put this in and try and run it on a production environment. If you don't have a test environment, make sure that's set to true. What that will do is it will stop the script actually performing any actions, but what you will get is a dashboard and all the logs. The logs are very verbose. It tells you exactly why it's doing things. So mark that up as true, and you can sort of run it in an audit mode, and it will tell you what it would have done with your infrastructure had it needed to do something inside and outside of those times. So I always recommend put it in, run it for a couple of days with that, see what comes out of it. So when we run that configuration script, what that configuration script does is it creates an XML file which is actually read by the main decision-making script, and it uses those parameters. Now, the reason there is a create config script rather than you just generating an XML yourself is because PowerShell natively uses that XML file that can read all of the types of parameters, including what types of variables they are, and just reuse those. It also encrypts the password that you put for the service account into an SSL key and cert, right? So you do not need to leave that in there. Once it's out of it, remove the password from the create config script, and no one will know it. All right. So once that's all completed, we can test it. So I've got a video here that you can sort of, I'm gonna just narrate. So here's a test machine with me setting this up, right? So I'll hop over to GitHub to start with. Download the code. And as I said in the PowerPoint, I'm just going to take that. I'm going to pop that in a folder on the C drive. Nice. Right, so we've got create config. That's the first thing that I'm going to run because I need my config XML. So I'm going to fill in some details here. First one at the top, I'm going to change the instance name. This is the title of the dashboard. So you can run multiple instances of this if you want to manage different delivery groups or different machines in different ways. You can change that so that the dashboard relates to delivery group or whatever it is. My machine prefix and delivery controller. So that's my delivery controller name. Then I'll amend my prefix. Right, and that's just my machines are called XDS HMP-01234556. Set my business hours, set my business days. So as I said, Monday, Tuesday, Wednesday, whatever you want. How many out of hours machines I want and how many in hours machines. How I want to scale my machines. So I'm going to scale these by session. And I want 6 sessions per server before I spin up another one. Now those numbers are average across the entire farm, so it'll be an average of 6 across 6 servers. Remember to set your script run interval. Okay, that is how often you're going to ask the script to run. We've put it in testing mode, and now I'm putting in my service account details. Remember to set your execution mode or your execution policy to unrestricted, otherwise it probably won't let you run it. I haven't signed them, so just so you know. All right, cool. And you can see there that's generated an XML file. So if I have a look, I've got a config.xml file there. Brilliant. You can edit this directly if you really want to. It's just a bit kinder with the PowerShell. Right, but you can see all of the details that I've put in there. So now what I'm going to do is just edit the main decision-making script. If I run that, it's going to read the config file, run off, and it's going to talk to my delivery controller. And you can see there, it's going to grab the farm info, create me a dashboard. Right, now that's what the dashboard looks like. You can tweak this yourself. I'm not a web page master, but there's some nice JavaScript graphs in there and things. I've only got one data point on the graph right now because it's the first time it's run. So I've just kicked it up again just to show you that it'll refresh the dashboard. And the navigation is kept inside each dashboard file, right? So it spun up 3 servers for me because that's what it needed to do. Cool. Right. So configuration and reference, right? So the script does these things for you, spins up the machines, shuts them down, and there's a ton of options, right? And it really does need to be configured to your business and what it is that you need it to do. So there is a configuration reference which I put together before I did my last webinar on this for the Citrix user group. So I want to talk a bit about the behavior, and there's quite a bit of text in here, so bear with me. But the behavior when powering on machines, if there are machines in maintenance mode, it will always take machines out of maintenance mode rather than powering on new ones. That's purely a decision based on cost saving. So it wasn't like that when I first put it together, but I'd change it upon request. If you want to exclude a machine, i.e. you want it in maintenance mode and you don't want PowerScale to ever touch it, you can add a tag in Studio, and you can call the tag whatever you want in the config, and it will relate that and it will leave those machines alone. Powering down machines, depending on the configuration you set, it will either wait for the machines to be empty, or it will tell all the users via configured message that the server is going to be shut down and it's logging them off. All right, so you get first message, interval, second message, interval, shutdown. So it's controlled by that single config.xml file. So it's not too complicated. You haven't got to run off in different places. You can manually edit it, and there's comments in the config file so that you can actually see what the options mean. So what about test mode? I said earlier, set it to true, and all it will do is audit. Basically, it will tell you it's doing things and it will log that out, but it won't actually perform any power actions or log any users off. Performance scaling can be on or off. So if you just want this to spin up your buffer of machines in the morning, and then you want it to try and shut them down at the end of the day, and you really don't want it to touch users, you can just, it's so simple, you literally just turn performance scaling off and it will do the job. What about performance scaling options? So I think, as I mentioned, you can scale on CPU, memory, index, or sessions. Now these are thresholds, and these are thresholds that are set on the average of the whole farm. So what it does is it looks at every session server, takes CPU, polls the CPU, memory, takes the load index and the number of users logged on, and it creates an average across all of those machines. So just bear that in mind, it's an average. So someone asked me, can I do a mix of the lot? Yes, you can. That's what your load index is for. So configure your policies in Citrix, and then you can actually really be granular if you want to take into account CPU and memory and sessions, and it will react off that. It might take you a little while to get the mix right, but again, that's what test mode is for. What about monitoring? How does it do it? So it uses sim, as in sim classes in PowerShell to grab those. You can actually set the sample interval and the performance samples it captures. So I literally just look at CPU for 5 seconds by default in the config. The performance capture piece is also multi-threaded. So at the moment, you need to tweak that so that it looks at the amount of, you need to look at the amount of threads that you've got on the machine available, and you need to tweak that, otherwise you'll be running too many performance capture processes. So the reason that was done really is because I had some people in large environments with sort of, thousands of machines, and it's doing a performance capture on thousands of these. So they needed to beef up the server and up the number of threads. and it hacks through them quite quickly without really really upping the CPU usage too much. I was originally using PowerShell jobs, but to be quite honest, they're awful. So it's better to use run spaces if you can. So to force or not to force. So I mentioned users can be gracefully logged off, or we can forcefully kick them off given intervals. These are the settings for that. Okay, so if I force the user off, then I can then configure the interval and the message that will be sent to the user at each point. So there is a first and a second log off message. I just didn't fit the second log off message on the slide. But putting on the details, as I said, if you put it in test mode, it won't do anything anyway. It won't actually use the log the user off. It will just send the message. So bear that in mind. It does send the messages. So what if I want to exclude machines? I mentioned tags. By default, the tag is called excluded. Create a tag in Studio called excluded and assign that to the machines that you don't want PowerScale to touch, and it will just ignore them. It does create tags for you in Studio. So if it scales a machine on, it creates a tag called scaled on. It clears those off at the end of business hours and treats them like normal machines and powers them off. But just bear in mind, you will be able to see which ones it actually scales on for you. I mentioned the service account, and I mentioned it encrypts the password for you. So it pops it in a key and a pass file. So you don't need to worry about people seeing your password for your service account in clear text. Log files. The log files are, like I say, they're very verbose. I don't have a cap for them size-wise. What I do is you choose how many you want to keep, and it will rotate those logs every night. Okay, and it'll keep that many logs for you and just keep them under wraps so that they don't grow too large. The dashboard. I was very proud of this bit because it's just a static HTML dashboard with some JavaScript for the graphing, and it's all JSON based. But PowerShell writes all that and sort of edits the HTML on the fly to give you something that's got navigation to. So they're stored in a folder called dashboard in the same place the script runs, and you can set the retention for the dashboards too. Something that's quite important, you can choose when you want your dashboard to rotate. However, I mentioned the script run interval setting. If you are going to set your script up as a scheduled task and you're going to run it every 15 minutes, make sure that's in the script. It uses that script run interval as a buffer, as a buffer either side of, say, 4 AM in this example, to work out if it should be rotating the logs and the dashboards. All right, so just to be clear, once you've done this, it creates like a navigation up the top of the window there. So we've got current, and then we've got a date for every other dashboard that you can see. And that's pretty much what it looks like. If you scroll down, you'll see a bit more. So we've got the machine status, as in how many's on right now. Performance metrics, you'll have a configuration on the right hand side, and it also shows you errors if there's any errors in the logs. There's a little window that shows you that too, and your historical linkage up the top. Okay, cool. So I put together some very quick sample use cases, and Alex, I know I'm running sort of to time almost. I haven't got many slides left.
You're right.
I think we said 40 minutes, right?
Yeah, I can take over.
Okay, all right. So for organizations worried about cloud costs, obviously you can use PowerScale to power up machines, taking into account that deployment time that we talked about earlier. So it sort of addresses that in a way. Is it perfect? No, but you will really, what this tool does do is allow you to be able to play with that scaling metric to make it more aggressive in the morning or less aggressive or whatever. And you've got the dashboards there, so you can actually look and see what's happening, correlate that with something like Citrix Director, and you'll see if users are trying to spin up machines and there's none there. So there might be a bit of pain when you first roll this out and you start looking at it, but actually it can sort of help address that. And then you can force the users to log off, message them, let them know they've got to get off. and you can configure those buffers to be whatever it is that you need in line with what your costs need to run to. CPU and RAM contention. So a lot of organizations are doing a lot of, well, ones that I've had experience with, they're doing a lot of robotic automation, and they have machines and VMs running overnight that are performing tasks and running, and they need usually a little bit more grunt. So rather than buying more hardware just for those use cases, actually out of hours, you could shut down your on-prem Citrix servers and spin up your robotic automation servers, run 2 instances of PowerScale, have one shutting machines down and the other one spinning them up roughly around the same times, and just make sure you're getting the most out of your tin without actually having to buy anything else. And then someone wanted to use this with like a very specific use case, and it was about a controlled usage of an environment. And it was specifically with regards to users only being able to access the environment within certain periods of time. And I think it was something to do with some sort of training or compliance, but essentially they're using this script to do that. So just between a certain amount of hours in a day, they spin up some machines and then they boot users off. It's only between a certain time and only on certain days. So they use that to address this need. So that's pretty much me. Quotes and thanks. I always put something in here because I never do all this stuff by myself. I had Jake Walsh moderate for me when I first put this together, and he co-presented on my first presentation I did about this, and he was my moderator on my second, which is this exact presentation. I got the encrypting the credentials from Dennis Spann. Jim Moore gave me the cloud scaling slides and simulation code. So thanks for the inspiration, Jim. And Guy Leach managed to help me get run spaces into this and untangle my brain because it's not simple. So if you want to get involved in community, come and join the EUC, the World of EUC Slack. And there is a PowerScale channel if you want to use this. Cool. So I'm open for questions if there are any.